Okay, so here we have hold up, let me move over. We have dark shining on our center. Dark shining on our center, basically, and light on the surrounds. What does that mean? So dark is coming into the center. These are the photoreceptors. This is the bipolar cell. These are the, that's supposed to be an R, photoreceptors, okay? Right here. So what does that mean? A dark signal is being detected here by this photoreceptor, meaning that we are getting neurotransmitter release, meaning that this cell is depolarized. Right, so this cell is depolarized because it's dark and it's releasing neurotransmitter onto the bipolar cell. This is what we call the direct pathway or the on pathway right here. So what does that mean? On or direct is sign reversing. Okay, so because see how this dark photoreceptor is directly synapsed onto that bipolar cell, it is the direct or the on pathway, meaning that this is sign reversing. Since up here this photoreceptor was depolarized, this connection here will be hyperpolarized. I'm going to denote that by a minus sign. Okay. So let's take a look at these photoreceptors on the side. The photoreceptors on the side are receiving light, meaning that they are hyperpolarized. And why is that? It's because they're receiving light, meaning that they're firing less inhibitory neurotransmitter glutamate. They're firing less of it to their own direct bipolar cells. But we're not talking about these ones right now. We're talking about these ones right here. This would be called the indirect or the off. So we're studying right now the relationship on this bipolar cell here, and how do the surrounding photoreceptors interact with this bipolar cell right here, this one. So the off or the indirect pathway, we call it sign conserving, meaning that it conserves what's happening in the photoreceptor that it's coming from. Here, the on pathway is sign reversing. It reverses the effect of the pathway that it's coming from. So in the on direct pathway, the photoreceptor was depolarized, meaning that it's going to hyperpolarize the cell because it is sign reversing. In the off or the indirect pathway, it is sign conserving. Notice how these are hyperpolarized, meaning that these are also going to be hyperpolarized. This is a cumulative effect to shut down this bipolar cell and not allow this bipolar cell to see, and this bipolar cell to fire a signal to the ganglion cell that's telling the ganglion cell that we can see from here. And that makes sense because we're in the dark. In the dark, we're not supposed to be able to see. So because this photoreceptor is not receiving any light, this photoreceptor is perceived to be in the dark, it's not firing anything. Look at all of this inhibitory action. So that inhibitory action tells us that it's a cumulative inhibitory from here, inhibitory from here, inhibitory from here. This bipolar cell is not firing, this bipolar cell can't see. What else have we got? So this is called the direct pathway, and the relationship between the pathway is called direct. The relationship between the photoreceptor and the bipolar cell here is on. It's an on bipolar cell because this is a direct pathway, which means that if it's on, it's sign reversing. The indirect pathway means that it's not direct, it's an offshoot to a different bipolar cell, that its synapses, not the one directly below it, it's a different one, it's an offshoot. So this bipolar cell relative to that photoreceptor is an off bipolar cell. You think of it being off the path. It's not on the path, it's off the path. And that means that it's sign conserving.